So this is the Midas mission team. They have just returned from a successful mission in outer space, and they're going to tell us a little bit about our mission. Guys, could you tell us a little bit about your mission?
Absolutely. Could you move to the... Okay. So first we're going to introduce ourselves. I'm Nico Barr. I'm the team's projectile physicist, aka the person who monitors the asteroid, who determines how fast the ship is going and get the intersect of the asteroid and into orbit. I'm also the communication specialist, so I'm going to be the main presenter for you guys, but I will have these fellows introduce themselves. So, Tristan.
I'm Tristan, the main mechanical and electrical engineer of the of the crew, as well as the videographer, capturing all the footage that we've made into a video.
I'm Oliver, and I have the task of being the scribe as to writing down and cataloging everything that we find along our way.
My name is Anthony. I was a demolitions and collections expert. I was there for when we got into Earth orbit. We would blow up parts of the asteroid and take it back to the surface for collection and processing.
I'm Onakrit. I'm basically the pilot and the captain of the attractor beam.
Make sure we all speak up so that the system can hear us. Sometimes these mics are a little weak.
Alright, I'm Hardik. I'm the chief safety officer to make sure that people stay healthy on the flight.
So before we actually departed on our mission, we did a little bit of work with craters to kind of figure out what we're getting into. So here we have the height dropped of our model asteroids, the diameter and the mass of the impactor, and then the crater it created, the amount of rays, whether or not it has such an amount, and then just some comments on the sides. So a few key points that we're able to deduce from this data is that when you add more velocity or go from a further height, that's what determines whether or not you get a central amount, basically the velocity of the impact, like the force. So that's one thing that we deduced. The other is that proportional to the mass and diameter of the impactor, the crater diameter increases proportionally. So, thank you. About our mission, the asteroid we chose to excavate, basically, is called Yugu. And the goal was to reach Yugu at an appropriate speed to engage our light tractor beams, and we'll get more into that later. And then escort it into high Earth orbit, so then we can excavate the materials inside. Now the materials are very valuable, so that's kind of like the main purpose of the mission, is to retrieve those materials and those valuables, and then obviously study and sell them. But to do that, we need to dislodge them. And so we decided to use explosives, namely that, it's just TNT, to dislodge portions of the asteroid. We chose that one because it does not need oxygen, so it will work in the vacuum of space. And then obviously bring the portions back on our main vessel, because we went over there to the asteroid. So, the value of our mission. So, like I said before, the value of Yugu is about $80 billion. And along with its richness in iron and valuable metals, along with diamonds, because it's a mainly carbon-based asteroid, those are the main incentive, to retrieve those and bring them back to Earth safely. Along with mining, however, the researching that the asteroid can provide allows us to maybe provide some insight into whether or not asteroids can actually be habitable for humans, aka like gravity, any kind of water in that asteroid, and everything like that. So this is a little bit about the asteroid we chose, Yugu. So Yugu is this lime one right here. Earth is purple or blue. The closest approach of Earth to Yugu will be about here, December 6th, 2076. So obviously, I guess it's 2076. And it's about 1.5 kilometers away. In terms of space, they're 1.5 million kilometers away. In terms of space, that's not too far. So we did it then. The size is approximately 1 kilometer wide. It's more in a diamond kind of formation. So you kind of have like the cone on top and the cone on bottom, and then it's wider around the equator of the asteroid. The weight is 450 billion kilograms, which is very heavy. And then we put a little bit of tidbits about the actual asteroid. It's pronounced Yugu because, instead of Ryugu, because it was a Japanese mission called Hayabusa 2 which sent sent satellites about 2, 3, 4 years ago to collect samples and check out the asteroid. It's actually the first drones that have ever been landed on an asteroid. So that's how we know so much about it, and hence the familiarity is why we chose it for our mission. So if you could hit the live tracker, you can just click the link right there again. There it is, right now. So I'm just going to have that in the background as we move to our press questions.
Thank you, Nico, and thank you everyone else, the members of the team, for introducing yourselves. So we have a few questions here, and then we're going to open up for some questions from the press corps. So how long did your mission last? How long were you guys in space?
So the mission lasted about a month, and that takes into account ascension from the atmosphere, our travel to the asteroid, travel back, and then the excavation. So intercept towards the asteroid, around 1.5 kilometers away, didn't take too long. It only takes 7.87-ish days around that time, because we were traveling in space at about 2,300 meters per second, which is about average for a normal space vessel of that size. And so it only took around that time there and then back, and then factoring in the extra time got us to about a month.
So this next question is for your pilot and the captain of your tractor beam. Could you tell us a little bit about how you captured the asteroid and how your tractor beam functions?
So we first of all So our tractor beam uses light rays to slowly and gradually detour the asteroid, so we can slowly reroute its course towards Earth's orbit. So it takes about a few months to actually see progress in it. So basically, we'll be taking the tractor beam toward placing it to the side of an asteroid, and then during the course of the months, it slowly, gradually changes the course of the asteroid.
That's great, great technology there. Thank you for telling us about that. Can you guys tell us a little bit about your spacecraft?
The complete craft during the launch has 4 primary boosters with 2 sub-boosters built into the side of the primary boosters. The large thruster is to take us to right U-boot, and a light-based tractor beam is then used along with the nuclear thrusters to get us there.
Great, let's make sure we speak up. Like I said, these microphones you've got in front of you are a little weak sometimes. Do you expect your team to undertake any further missions to Yugu once you have brought it in closer to Earth?
Yes, so we are going to be traveling to the asteroid further times to extract more and more of its minerals. It'll take some time.
Great. Along the way, did you run into any unexpected challenges?
Yes, we ran into a major problem with our autopilot, which we had to manually reset because it was setting the course for a debris field.
Yeah, that's definitely. I'm sure that was very stressful. It's good that there was such a well-trained and crewed craft here. Outside of the implications and the value of your mission, do you feel like you discovered anything, or that your mission had any implications for the future of other space exploration or possibly habitation? I know you mentioned a potential study for habitation.
Yeah. So the prospect of having humans on asteroids could mean like closer travel to different celestial bodies like Mars or even further. And the main problem with that obviously would be gravity and atmosphere. And so in our travels to our asteroid, we made sure to research different things, especially when we brought it back to Earth, whether or not that could technically be possible, and that research is still going on.
So what other space phenomena would your team like to study together in the future?
In the future, we are looking into sending unmanned craft to go study black holes and to measure the forces and phenomena inside those.
Okay, very interesting, very interesting. We'll love to hear back from you when the time comes for those missions. Did you encounter anything strange or anything that surprised you while you were on your mission?
We weren't expecting to find the little drones that were deployed there beforehand. We kind of assumed that they may have accidentally bounced off or something. We don't exactly know the results of what happened to those drones.
So are there any particular comforts from your life on Earth, anything about living on Earth that you particularly missed while you were in space?
During our time in space, of course we missed gravity, we missed the people of Earth, the sun without extra radiation, which was a huge one, and the most important one, I'm pretty sure everyone missed this a lot, anime.
Okay, we got a lot of big anime fans on this mission. I take it. All right.
You got some good series on there.
And finally, before we open this up to the media here, to the outside media, who sponsored your mission? How were you guys able to undertake this mission?
Our mission was sponsored by the private company Ad Astra at Abyssos, and they kept the direct profits from the asteroid. However, we were paid a very large salary, along with a one-time bonus of $1 billion each when we successfully brought the asteroid back.
Great, great. And one final question. I missed this on my sheet here as I was speaking with you guys. I know that you studied some impact craters on the surface of this asteroid. Can you guys tell me a little bit more about what you learned there?
Yes, absolutely. So, Yugu contained 77 craters of various depths and locations around the actual asteroid. And one thing we found interesting is that there was one artificial crater created when the Japanese satellite from Hayabusa 2 fired a 2-kilogram copper mass into the side of the asteroid to study impact craters. The resulting crater showed like a darker subsurface material, so you can see that layered kind of rock, as well as creating an ejecta around a centimeter thick. So obviously not too much there, but it's quite interesting.
Great, thank you. Members of the media present today, are there any questions that you would like to ask this team? Any further information you would like to learn from them about their mission? Yes, sir.
So, do you have any idea how diamonds were on the thing? Because don't you need a lot of heat and pressure?
Yes, okay. So, Yugu is a Class C composition asteroid, therefore it is mostly carbaceous, so the carbon was already there. And so, since there is no atmosphere while it's orbiting Earth, there's an immense amount of heat and pressure, obviously, as it's orbiting around. And so that created diamonds to form in the inner layers of the asteroid.
I have a question for the demolitions expert. In what ways were safety precautions taken when using the TNT to dislodge material?
They were all controlled explosions. It was not just setting TNT on the asteroid and blowing it up. We dug small holes into the asteroid and then put TNT inside of it and blew it up.
Here.
So when you used the tractor beam to move the asteroid, was it also your team that did that, or was that a previous mission that worked on getting the asteroid into Earth's orbit first?
So that was also us. So we sent 3 additional rockets with us, and they all contained the light beams. And so they were all sent basically around the same time, and they all converged at the same time. So we could use the 3 different ones to kind of create a triangle, which allowed us to move the asteroid easier. So yes, that was us. Yeah.
Follow-up question, were the other rockets manned also? Or
No.
were they-
Just our manned vessel that we used to gain the samples and carry the explosives to blow up the asteroid.
There was a lot of remote control monitoring on that.
Yeah. And that is why we have a tractor beam specialist.
Are there any more questions from the media pool today? Right, are there any final thoughts that you guys would like to leave us with before you have to go today?
Well, thank you for coming. We will be sure to update you guys with the whole black hole explorations. I was thinking about the mining, but yeah, that's really all we have.
Well, thank you for your time, Midas crew, and thank you for your contribution to space exploration.